In this next section, what we're going to look at is we're going to look at atoms that are ions. Now, molecules that are ions. So when you draw the Lewis structure of a molecule, that's an ion. One of those to look at is our PO4 3-. We want to make sure that we're including those charges. So PO4 3-, we should have a total of 5 valence electrons from the phosphorus, plus 4 of those oxygens with 6 each, plus another 3 valence electrons from that charge. The minus means that we add electrons. The positives mean we need to take away electrons. So we should have a total of 5 plus 24, which is 29, plus 3. So we should have 32 valence electrons total. Now our phosphorus is going to be our central atom. We have our 4 oxygens split out around there. So there's our central atom. Oh, sorry, that's our bond skeleton. So we've used up 8 of these. So we should have 24 valence electrons. I'm going to fill in from the outside in. Used up all 24 of these valence electrons. We have no more left over. And right now it looks like everything is great. So if we thought this was our Lewis structure, then we should bracket the whole thing. We should put its charge up there, and we let people know that this is the phosphate ion. That's why we have to have the brackets, is because we're putting that charge there. If we don't have that charge, then people might think that we meant to draw just PO4, in which case this would be definitely wrong for it. We would have way too many valence electrons. Now, when we're drawing our structures, it does ask us to put in our formal charges. So we have to look at each of those oxygens and we have to calculate its formal charge. And so our oxygen should be 6 valence electrons, minus 1/2 of our 2 bonding electrons, minus 6 of our unbonded electrons. So we should get, not 0, we should get a charge of -1. And so we should put a minus charge. And so your formal charges, you use the charge and a circle around it to indicate whether it's a formal one. If it was -2, then we'd have it something like that. And then we want to check our phosphorus. Our phosphorus has 5 valence electrons. We'll do it in a different color. It's got 8 bonded ones, no lone pairs, and so it's a +1. So we might stop there, and we might think that this is our best Lewis structure. But we have this positive charge and we have this negative charge, and so we would like to get rid of that if we could. So I could draw an alternative structure to this. Instead, I might draw something that looks like this. Now my single bonded oxygens still have formal charges on them. But my phosphorus in that center no longer does. 5 valence electrons minus 1/2 of 10 valence electrons minus no bonding is 0. This single bonded oxygen doesn't have a formal charge either, so we don't have to put those. But all of this still is an ion, so we still need to have the 3- on it. And so this is a better structure than the one that we first started out with because it has fewer formal charges. Now, one thing to check for your ions is your formal charges and your ion charge should match. So if you have a formal charge up here on the right-hand side, oh, sorry, not formal charge. If you have an ion with a charge up here, but you have no formal charges on the inside, then something's not right. You don't have the right number of electrons, or one of your formal charges wasn't calculated correctly. This should match everything that's on the inside, the sum of all those pieces. And you can see for both of them, they did match. 3-, We have 3 minus charges. 3 minus, we had 4 minus charges, but we also had a positive. So those two things should always match up. So now that we've seen our two options, we know that this one should be our better structure. So that should be the one that we're drawing. And now you want to think, well, is there a reason why the double bond had to go to our right-hand side? Couldn't it have gone to the left, or couldn't it have gone to the bottom or the one on the top? And so you would go through that and you would look at how many of those options might there be. If they're all the same, equally as likely, then that's our resonance. If they're not all the same, then you want to choose just the ones that are comparable. An example of that is something that looks like this. While it does have a right number of our electrons, this is not going to be as good of an option because we have that negative charge on our phosphorus instead of being on the oxygen. Right? So it's not as good as an option. It should not be considered a resonance structure. And then the last part, when we're doing this setup, when we made that choice to add in that double bond, remember that that means that we are an expanded octet on phosphorus. We can do it on phosphorus because it has an open d orbital, because it's in period 3 or higher. If phosphorus was nitrogen, we would not be able to do that. So keep that in mind as you go through your structures. If you've already done all your structures, then make sure that any ion should have a FOMO charge indicated somewhere in there. Because if you have a charge out here, it means you have to have either more electrons or less electrons than usual. So some atom inside should have more electrons or less electrons than usual. All of your ions should have these brackets with their FOMO charge outside of your Lewis structure. Make sure that you have those as well.